G'day, I'm Ryuki-san Dev, and in part 12 of this series, Unity for the Absolute Beginner, we are on our final part of our first simple game. Alrighty, so this is a continuation from part 10 and 11 of the series. This is the third and final part to our first simple game. This video might end up being a biggie, but we'll see how we go. The link for part 1 and 2 of this game should be on the top of your screen right about now. Shortly we will work on a new game to cover new Unity items and keep the learning process going. So we have the basic game with objects falling and the player that moves to avoid them. So now we need to make it a little more interesting. This video will be a rather big step up from the previous two, so get your thinking caps on and let's get into it. Right, so we've got our game open from where we left off in the last video. So the first thing is we only have one object coming down at the player. We should probably add some more, make it a bit more interesting. So we're going to grab some more foods and drag them up into our hierarchy. I'm going to grab an apple, a pea, and a mushroom. And I'm going to name them enemy 2, enemy 3, and enemy 4. Don't have to do this, of course, if you don't want to, but I just feel like doing it. Now, yes, we could have created prefab variants from the original one that we used, but we'll keep it simple this time. And besides, some of the meshes are different shapes and might require different shaped colliders anyway. Now, select all of the new enemies in one group and reset their transform. Then add a rigid body. Turn off gravity and set drag to 8 and angular drag to 0. And grab your move tool and drag each enemy sideways on your scene so that you can see them. Now we have to give each enemy a collider. My apple and mushroom should be able to use sphere colliders, and my pea will use a capsule collider, I suppose. So as per the first video, create your colliders and have each one surround the enemy. I'll do mine real quick and I'll be back. Alright, we're back. Okay, drag the enemy script onto each of your enemies. Then select all of your enemies in a group again and change their force to 2. Okay, so they are ready to be put away as prefabs now, so drag each one into your prefabs folder and make them original prefabs. And now you can delete them from your scene. So now we need to create a list of objects and have our game manager script randomly select an object each time. So let's double click our game manager script to open it. So we already have a reference to a game object and assigned an enemy to it from our first video. Now we will just make it an array. So we just put 2 empty square brackets at the end of game object up here. Now it's not going to let us save the script because there will be errors in our instantiate line. We're not specifying the array index value. So temporarily, let's just put a square bracket with a 0 in the middle after enemy in both places of that line. Now we should be able to save and get back to the editor. Cool. So now if you click your game manager object, you will see the enemy is now a drop down because it's a list. Enter in the number of enemies that you have created. For me it's 4, and push enter. And now I have 4 slots to drag in my enemy prefabs. So drag each of your enemy prefabs into the fields. Actually, while we're at it, let's change the spawn rate to 0.5 to make them spawn a little quicker. Cool, and now of course you can see the element numbers. Those are the index values. We entered 0 in our script, so if we actually run the game now, it will spawn whatever object you have in element 0. So now if I quickly go back into my script and change the 0 to a 2, then it will spawn what's in my element 2. So you get the idea. Alright, now we need to make it random. So let's get back into your game manager script. So we want a random index value each time the script cycles, so let's create one. So above your instantiate line, type in int index equals random.range, and it's between 0 and enemy.length. And now replace our index value with the variable name index in both places on the instantiate line. Alright, what did we just do? We created a local variable and it will be a random number between 0 and the length of our list. My list is 4 objects, so it will be between 0 and 4. I could have just typed in 4, but then later if I added more enemies to the list, then I don't have to change anything in the script because it will already know how long the list is using enemy.length. Alright, let's save and play. Cool. It's spawning in random enemies from our list. Okay, so what's next? Well, we've got to keep score. So I guess for each object that doesn't hit you, we could get a point. So let's do that. Let's open our game manager script again. So first we need to store our score, so let's create a variable for it. We'll make it public for now so we can see it. So let's do public int score equals 0. Now, our game manager script has no idea when an enemy floats off the screen, so we're going to need to create a function that will increase the score and then get our enemy script to call that function. Yep, that's right, we will make the scripts talk to each other. So below our collision function, let's make a new one. Public void update score, and we're going to have a parameter this time, so we're going to do int and add end. And then in between the curly brackets, score plus equals add end. That's basically the same as typing in score equals score plus add end. It's just a shortcut way of doing it, plus equals. You remember custom functions, we can have parameters. Well, we're using one this time. So this function can be accessed from other scripts because we made it public. The addEnd is the name of a temporary variable used to accept the number when the function is called. You could call it anything you like. So basically when the function is called, it needs to be called with some kind of number. So for example, rather than just typing an update score with empty brackets, to run this function now, you would have to do something like update score and then in between the brackets a number. The function will add that number that it receives to the score. We will visit this again after we get the enemy script to call it. So let's save this and open our enemy script. So first we have to create a link to the game manager script so that we can access any public functions and variables that it has. So firstly we will type up here public game manager script. Then in start, type in game manager script equals game object dot find game manager dot get component game manager. It's kind of a cryptic line, huh? So we've done something similar to when we referenced rigid body earlier. We've created a container or a variable to hold the class game manager, which of course is also the name of the script, and we have named the container game manager script. Then in the start method, we have assigned the actual game manager script to it. So now we can call any public function from that script, or if you like, class. So in our if statement, if you type game manager script dot update score, and then in the brackets, the parameter we're going to pass is 1. Cool. So now each time the enemies get to the bottom of the screen without hitting you, it will call the function in Game Manager to add 1 to the score. So let's save this and test it out. Now click the Game Manager object in your hierarchy so that you can see the score, and hopefully you've got play focus mode on so that you can see the score increase, and press play. And we'll just wait for an enemy to get past us. Cool, score is updating each time the enemy gets to the bottom. Alright, so next we want to display the score on the screen. Would be a lot better. And also have a restart button when you die. So we'll dive into our first GUI. So right click in your hierarchy and select UI and Text Mesh Pro. And you're probably going to get prompted to import TMP Essentials. So import those and close the window. Now you will notice in your hierarchy that Unity has already created our canvas for us and then dropped our requested Text Mesh Pro text inside it. So anything you want to put in the GUI needs to go inside the canvas. Right, now if you double click the text TMP, your editor should zoom out so that you can see some of your canvas. You might have to zoom out a little more because it's pretty big. Then on your game window, you will see what it would look like when the game is running. So click the Move tool and position it where you would like it. I'm going to put mine up here in the left corner. Okay, so notice in the inspector you have anchor presets. Click it and select where you would like the text to stay. Mine's on the top left, so that's what I'm clicking. Now Unity will do its best to keep it there no matter what resolution. Right, so I'm going to rename this to Score. And make its text Score: 0. Now you can fiddle around here and change the font and colors and everything to your liking. I'm just going to leave mine as default for this one. Now while we're in here, let's also create our button to restart the game. So right click on your canvas folder and select UI again, and this time select Button Text Mesh Pro. And rename the button Restart. And if you click the little drop down arrow to see the text part of it, and change the text from button to restart game. Now at the top of the inspector, let's disable the button for now. It's still there, you just won't see it until we enable it from our script when the game ends. Okay, we're ready to work on the score first, so double click your Game Manager script to open it. Right, so since this script is the one keeping score, then it's only natural that it should be the one updating the score in the GUI. So first we need to get a reference to the actual text field. So underneath your other declarations, type in public Text Mesh Pro GUI score text. Now, if your Visual Studio was smart, it would have already dropped in a new using statement at the top of the script using TM Pro. If it didn't, then you're going to have to type it in manually. All the Text Mesh Pro stuff needs this library to work. Alrighty, so save the script and go back into your editor. Click the Game Manager object and you will see a new field for Text Mesh Pro. Drag the score from the canvas into that field. Cool, we now have a link for score text. So let's get back into the script. Now we just simply type in our update score function, score text dot set text score colon and speech marks plus score. So when this runs, it will update the text field to what's in the speech marks and then the actual score after it. So let's save this guy and run. Let's wait for some enemies to get to the bottom here. Cool, we have a score. Alrighty, so now on to our restart button. So now let's open our player script this time. So we need to create a link to this button as well, so we can enable it when we need to. So make a public game object restart button. And now we need to enable the restart button when the player dies. So inside our collision function, delete the scene manager line because we're not doing that here anymore. And type in restart button dot set active true. Cool. So this will make it visible when we get hit and the game ends. So let's save it and get back into the editor. Now if you click the player object, you will see the restart button in the inspector. Drag the button from your canvas into the empty field and we're done. So now our script knows what it's setting active. Right now, just the button itself left to do. At the moment, if you click it, nothing will happen. So we need the game to restart after the button is clicked. It's no good putting the function in the player script because when the game ends, the player is destroyed, so the function won't exist. So let's get back into the game manager script. And let's make a new public function just before the last curly bracket at the bottom of the script and call it restart game. And in between the curly brackets, put our load scene statement, scene manager, dot load scene gameplay, or 0. So now we have another function that we can call from outside the script. So let's save the script and back to the editor. So now we need to tell the button what to do when we click it. Click on the button in the hierarchy and scroll down in the inspector until you see on click. Click the plus sign to add an action. Drag your game manager from the hierarchy into here. Now where it says no function, click and select game manager and then select restart game. That's the function that we made. And that's it. When that button is clicked, it will run that function and of course in that function it reloads the scene. So let's press play and try it. Objects coming down. Getting points. And I get hit. And there's the restart button. Click it and the scene reloads and starts over. Cool. But when we die, the enemy keeps spawning and I'm still making points. So we need that to stop. So let's stop the game and back into the game manager script. So we need a condition that the game is actually running in order for stuff to spawn. So let's create a different type of variable this time, a bool variable. It can either only be true or false. So public bool game running. Now in the spawn enemy function, we need to say only spawn if the game is running. So above all the code in the curlies, type in if game running, then select and drag all 3 lines into the curly brackets. So now things will only spawn if game running is true. Right, let's save and get back to the editor. Now, if you ran the game right now, nothing will spawn because our variable by default is false. But we need to specify it in our player script because it's the one that has the collision to end the game. So let's get into the player script. So now player needs a link to game manager so it can give game running a value. So as we did earlier in our enemy script, we have to create the link. So exactly like in the enemy script, do private game manager script. And in the start, we do the same again. Game manager script equals game object dot find game manager dot get component game manager. And now we can type game manager script dot game running equals true. And now in our collision function, we can put game manager script dot game running equals false. So now when the player dies, game manager script knows about it and it will stop spawning the enemies. And save the script. So we've stopped spawning when the game is over, but there will still be existing enemies falling down the screen and they will give away points. So that's got to be rectified as well. quickest way is to put an if statement in our update scores function in our game manager script. So let's do that. So open your game manager script, and above the 2 lines of code in our update score function, type in if game running, and then grab the 2 lines of code below it and drag them into the curlies. Cool. So now score will only update if game running is true. And save. And run. Right, let's get a few points here. And let's die. Cool, so the spawning has stopped and the last ones dropping are not giving us any points. Done. So there's a lot of tweaking you can do here. If you wanted to make the game more difficult, you could change the spawn rate in your game manager. Try 0.1 or even less to make a whole bunch of objects come down. So this video is probably getting crazy long, but you know what? I'm going to do one more thing. I'm going to make an exit button and have it quit the game when it's clicked. And then we are going to compile the game so it runs outside the editor. So first of all, let's create another public function in Game Manager to quit the app. So into the Game Manager script, and let's add another function below our restart game, public void quit app. And in between the curlies, just put application.quit. Control S to save and back to the editor. And now we need to add another button. So let's right click the canvas in your hierarchy and select UI and button text mesh pro and rename it exit and change its text to exit. And you probably need to re-enable temporarily your restart button so you can see it and arrange both buttons how you want them. And now disable both of them. Right, click the exit button and scroll down the inspector for that on click again. And do as we did before, add an action. And drag your game manager into the object field. And select the no function drop down and select game manager. And then quit app. And now all we need to do is enable it when the game ends. So back into our player script. And we'll create a link to the button, of course, with public game object exit button. And then we're going to set it active when the game is over. So in our collision function, exit button dot set active true. And save and back into the editor. And click on the player in your hierarchy and drag the exit button into the exit button field. Done. Now the exit button isn't going to work when you're in the editor. There are ways to make it work, but we're not going to do that today. But once this game is compiled, it will exit the game. Okay, so the last thing to do is compile the game so it runs outside of this editor. Now, firstly, before we compile this game, we need to change a couple of things to make it playable outside the editor. To be honest, I wasn't planning to cover this for this game, but because I added add force in physics, I'm somewhat forced to mention this now. If you were to compile this game as it is, the enemies would probably move far too slowly and it would be unplayable. So first, let's change what we need to change. So get into your enemy script and change the void update method to fixed update. And Control S and get back into the editor. Now select all of the enemies, all of your enemy prefabs, and change their force to 20. And also do a quick test run just to make sure that it runs okay in your editor, that they don't kind of fire down the screen at the speed of a bullet. They should come down nicely. Now I'm not going to go into too much detail here because this actually warrants its own video. But in short, there are basically 5 methods. In running order, they would be awake, start, fixed update, update, and late update. They all have their uses depending on what you are trying to achieve, but generally, fixed update is usually the best option for anything dealing with physics. Now, this area is far too big to cover on the end of this video, so I will make a separate video on these methods at a later stage to make it easier to understand. So let's get on to compiling the game. So click File and Build Settings. Now double check that your scene is in there and that you have Windows, Mac and Linux selected, and select Build. And it will ask you for a folder to put it in. I'm going to make a new folder here on my desktop and select folder, compiling. Cool. Save the project, close my editor. There is my game, and run. Cool. Alright, so everything looks normal, stuff's coming down at a good rate. And let's see. Yep, when I die, there's the exit button, and if I click it, boom, the application closes. So that's it. I could just keep going and going on with this game, but I know I've got to stop somewhere for a new one. But there is a ton of stuff you could do with this, obviously. And who knows, maybe I'll come back and revisit it later. So let's do a recap of this game. So we covered a lot of new stuff in parts 1, 2, and 3. I feel like the third video was a little bit rushed, so apologies if it was. There was a lot of toing and froing. There's 2 reasons for that. One was I just wanted to keep demonstrating how things worked. And secondly, because I was adding things along the way. Truth be known, if you actually had planned this game on a piece of paper first, then it would probably only take you about 20 minutes to make it. I will be doing a few other videos to cover a few things in this game that might have gone a little too quick. As always, I'm open to questions and suggestions. Also, I didn't worry too much about my private versus public items as I probably should have, but just keep in mind it is important to keep things private where you can and only make it public if you really need to. The next game will contain stuff that this one is missing, such as sound, particle effects, saving scores. Actually, the saving scores part I might actually make a separate video on first, though, along with persistent data, i.e. data that sticks between multiple scenes. Now, in the next video, I think before I make another game with more features, I'm going to do a video on functions. I think they definitely warrant a video of their own, and they are something that you will absolutely be using all the time. So I hope to see you in the next video.